Hello, in this second video we will continue our look at the basic select statement in the SQL programming language. One of the more common options you would like to use is to order the results. So this does not change the way the data is stored, but it will change the way that results are displayed. So when you select the columns that you want to see and the location you want to pull the data from, you can identify how you would like the data displayed by using order by. Indicate either the name of the column or the number of the column 1, column 2, column 3, or 4, whatever number of columns you're getting back in the result set. And you can also indicate whether or not you want to see the results in descending order or ascending order. If you do not specify, you will get ascending. This actually can be changed on the database as a setting, but most of the time that's what you'll see. A before B, B before C, unless it's been configured otherwise. In this case, instead of 1 before 2, I start at the top of the number scale and work my way down for the product ID. That's because I have descending. Notice that putting descending on one column does not affect the sort order on the other columns. The type column is starting at the lower end of my spectrum here with B before P. And I'm seeing P before M, well, because I'm within that same number. The first column being sorted takes precedence. Here we see M before P because we're on a publisher ID, pub ID 0877. If we move to a different publisher ID, we see once again we start off with the lowest letter of B before P. Price would follow the same pattern. And once again, you can actually just use the column number, starting with column 1, to define which column you want to sort by. Often you'll want to display data with aggregate values. For example, let's say I only want the maximum date from the orders table. I can use the max function to extract that. Then, based on that maximum date, the last date that an order was placed in this database, way back in 1998, I can see a list of the customer IDs and order IDs that were in that table based on that one date. I can see the minimum using the minimum function. So here is our ship dates from the orders table. Notice that the null values are showing up first, and then after that, we see actual values here for the other dates. The last value, the maximum value, was 1998. The first value was 1996. Whenever I'm dealing with dates, it's usually good to establish a range of values that I want to stay in. Otherwise, it's easy to exceed the boundaries and not see any data. I can get the average. Maximum, minimum, average are 2 or 3 of the very common ones you use, but just using the average function. And in fact, sum, average, count all, minimum, maximum, all ones you'll find useful on a regular basis. Sum adds things together, average adds them together and divides them by the count. Count counts how many items are in the result set, and count all counts items that are in the result set but doesn't exclude null values. If I look at the titles table, let's say I just go ahead and change this over to see all, the star. Select all from the titles table. I see all of the columns, that's what the star is going to give me, from the titles table. You'll notice that if I look at this, at the bottom corner over here, I can see there is, let's see, where are you? Right there in my way. Yeah, just the way it works. I can see there's 18 rows of results. So the count would normally be 18. But if I look at the column year-to-date sales, I see there's a couple null values. Turns out that if you count the column itself, the nulls will be ignored. That's going to be true of sum and average, count, minimum, maximum. The nulls are always going to be excluded. An exception to that is when you use count all or count star. And in that particular case, it's not actually identifying any particular column, it's just counting all the rows and all of the columns. As such, it's set up to exclude nulls. (18) versus 16. Sometimes it's good to know that, because if you want to make your own calculations, you may have to, well, write your own code. For example, the average of sales in the titles table of the pubs database. Notice I'm using Northwind, but I'm actually pulling data from pubs just to show how you can pull data across database boundaries if you fully qualify it. But anyway, if I go over here and I look at this, I see two different numbers. Now, the reason for that is the average function all by itself would add up all the year-to-date sales and then divide by 16 rows, because the average function doesn't take nulls into account. If indeed I want to divide by 18 rows, including nulls as if they were a zero value, I could use my own calculation like this. So as you start getting to more advanced calculations or programming, you may actually have to build your own using these basic functions. But as you can see, it's not difficult to do. You just have to understand the basics. Now, so far, in every occurrence of our examples here, we're getting back a single result from the answer. For example, I see I get one single row of data and another single row of data. And for each of these three statements, where I have the aggregate function max and min, I get back a single row. But if I get back multiple rows, I have to do something a little bit different. What I have to do is I have to identify if there is a duplicate value, how I want to deal with that. Well, what I typically want to do is I want to group those together. I want to count them as a single value. I want to group things together. And as such, when I'm working with aggregate functions, I often will use a group by. Let's take a look at an example. I'm going to look at data from the order details table in Northwind and the products table. I'll combine them together to show some results. I can see that this product name of Alice Mutton was ordered in quantities of 30, 15, 15, 40, 8, 20, 70, 36, 2, 45. Wow. Apparently it was a popular product. 50, 10, and so on. Eventually, I'll get into a different product. But currently, all of these are orders with their quantities. 37 different orders. You know, I really kind of want to see that group together, so I'm going to aggregate them. I'll do so by summing up the quantity. Instead of being just quantity, I'll make it total quantity using a column alias. And to make it look nice, I'll go ahead and order it as well. Anyway, when I want to group the data together, I can use the group by statement, and you can see that Alice Mutton is now combined. Not sure the order by is really helping me all that much, but I can see how this button's been combined into the value. If I were to leave off the group by, it would not be happy with me. The reason for that is that the product name shows up multiple times in the result set, but the quantity, when you sum it together, would be 1, and it doesn't know how to display that. The error message is not bad, except that if it's on a smaller screen, you won't see the end of the error message, which tells you you're missing the group by statement. And often what people do is they'll just read the first part and then kind of give up. The actual problem is detailed at the end of the error message, which just kind of goes to show you, always read the entire error message. Anyway, the rule of thumb is, if you have in a select clause any columns that are not being aggregated, you need a group by. If, on the other hand, you have a situation where all the columns are being aggregated, you don't need a group by. It's only necessary when you mix aggregated columns in the results versus and non-aggregate columns in the result set. After the data is grouped together, so let's say I go ahead and I get 2,155 rows of data. Looking at the little row count over here. After the data has been grouped together, I can go ahead and apply a filter by using a where clause. The way the SQL statement runs is basically it looks for what column names you want, but only after it joins the data together. So it joins the data together and then filters out which columns you want to display. It joins it looking at all the columns based on product ID and product ID, then filters out the columns you want to see. That's the second stage. And then actually the third stage would be ordering the data for the results. Let's add another clause in here, a where clause. First thing it does is it goes through and combines the data from multiple tables. Second thing it does is only shows you some of the data based on rows. The third thing it does is shows you only some of the columns. And then the fourth thing would be ordering the results. If I add a group by in here, gets all the data from both tables, filters out the rows, filters out the columns, finds that we have an aggregate in here, and as such requires a group by. So instead of going through and doing that third, it jumps down this and does this third, and then comes back and shows only the columns. And of course, after that, it does the order by. One thing that's kind of hard for people to kind of wrap their heads around at first is the fact that the select statement doesn't necessarily run in the same order that it's typed. Basically, what you're doing is you're telling SQL Server that this is the recipe that you want to use, but not necessarily the order that you want everything to flow in. And most of the time, it guesses exactly right, and you don't have to worry about it. There is very, very few times where you need to control it. But at first, when you're trying to wrap your head around the way programming works in SQL, it can be a little confusing. You will get used to it in no time at all and find that just trying to think about the order that things run in can actually be kind of confusing because you have to slow the whole thing down. But when you're first beginning, I think it sometimes helps to kind of slow down and think about how things must run. Things have to be grouped together before they can be summed. You have to group the products together first before they can be summed. I mean, if you look at it this way, I would have to group products together first before they could be summed. So if there was any time where the product showed up twice, I want to group them together and come up with a product, a summation of 240. And that's what we're doing here. We're doing the grouping first and then coming up with the sum. Another clause you can add on is this having clause. After things have been grouped, we can then do an exclusion. I got that value of 240 when I added things together and grouped it. But originally the filter of it having to be greater than 100 was only applied to the individual rows. After things have been grouped, you can apply another filter saying where the result of the aggregate is greater than 200. The having clause gets invoked after the grouping has occurred. Having is like a where clause, but it's only performed after a group by. It's possible to go through and apply a having without a where clause. It's basically like a where clause, but once again, it only is applicable after the grouping has been performed. So if you see having and there is no where clause, that's all that's going on. You will sometimes see people using having as a filter. So the aggregation is done and then it goes through and shows that. But that's kind of confusing in some regards because I can certainly see that these sums are indeed greater than 100. Let's make it greater than 1,000 and see if there's any of those. And if we had used the where clause, we'd see nothing. Because the individual quantities before they're summed never actually reach that value. Another option that you may find useful or certainly see in other people's code is the distinct option. Basically, if I look at the customer IDs in the orders table, along with the order dates, I'll see that this customer bought something on this date. And if I go down here far enough, I'll probably see a similar situation. Right now, I see that there's 830 rows of data. Let me go ahead and put that distinct back on there and run it again. I see 823 rows of data. Now, that being the case, that means that at some point in time, a particular customer bought something on the same day twice. Notice that I'm not recording hours, minutes, and seconds, so they could have bought something on the same day. I could have bought something on the same day in the afternoon and then later in the morning. Ordered by column 1, then column 2. Now, it'll make it a little bit easier. We'd have to, here's one, nope, actually that's the 3rd and the 13th. What we'd have to look for is something that, same customer ID, but somewhere in here we have the same date. I know there's 7 of them, and we can actually program that, but that's a little bit more advanced than we're going to deal with right now. If we look down here long enough, we'll find an example of it. The distinct clause says, if you have a duplicate row in the results of your query, only show me one. Only show me one instance. It's not a duplicate result in the table, but in the actual results of the query. If you have no other restrictions or any other calculation, then it results in the same thing. Another clause that you'll see, an option here, is the union clause. The union clause combines data from multiple result sets, not from multiple tables per se, but multiple result sets. So for example, I have an aggregate value account and a column alias, and I have just a text string for 1996 and a column alias. When I run this, I can see that there were 152 orders that happened in the year 1996. Column alias year, column alias customer orders. I'll do that for another year. Hey, let me change this, 1997. 408. Now, I'd like to combine those. Let's do 1998. I guess we're going to do all 3 years. We did see earlier that there were 3 years. Okay. I'm going to combine them by using the union command, the union clause. Now, I don't want to end the statement because it continues on. This is actually one large select statement with multiple select clauses. First statement, 1996. The next one's 1997. Next one's 1998. Notice, though, that when I do this, I only end up with one column alias at the top. By the way, if I had put a different column alias at the bottom, it would be ignored. Only the first column alias gets accepted. But with this, instead of having 3 result sets, 1, 2, 3, the union clause, I end up with 1 result set with 3 rows. So instead of having 3 result sets with 1 row, I end up with 1 result set with 3 rows. Depending on what you're trying to do, that's pretty handy. One example of what I might try to do is I just go ahead and take this data and copy it into like an Excel spreadsheet. Copy it, paste it into an Excel spreadsheet. It'll act as a single table of data I can make reports from. Another option I find quite useful is the top command. Only give me some of the data. So instead of getting all the data, I only want a sampling of the data. I could say, okay, I only want the top 5. Now, if you are saying you want the top 5, you have to indicate what the order is. Which top 5? If you don't, it won't know which ones you want to pick from the sample. In this case, I'm getting the top 5 based on the quantity. It's the order by that chooses which 5 of the results I'm going to see. If I were to look at that data without the order by, it's basically going to give me, it's not exactly a random sampling, but just the way it's been stored. You can see that the order numbers are sequential. So, in general, if you're using a top command, you want to use the order by command to go along with it to make sure you're getting what you want to see. So 130, 130, and then we run out of the 130s in that table. And we go to 120, 120, 120. If there are any more orders that have 120 on the quantity, we're not seeing them. Well, that is unless we put in the with ties option. In that case, after the first 5, if there are any values that would also be the same value, it'll continue on until it runs out. whether that runs out at 120, whether it runs out 5 or 7 or 6 or whatever, in this case it's 10, it doesn't, that's not another 5. It just happened that this particular value ended. So any tied values after that 5th value will be included. You can even use a percentage, which is kind of a nice option. In this case, I'm going to say I want the top 1% of the data. Now the total number of rows is 2155. Let's see what we get when we get the top percent. So according to this, we got 23 rows of data. So it's interesting. This would have rounded up to, I don't know, 22, it looks like to me. Oddly enough that we got 23 rows. Oh, wait a second. Because I ran both of them at the same time, this was counted in the little count number of rows affected over here. So it really was rounded up at 22. Now we can see 22. Of course, for that few rows, I can just scroll down. Sometimes it's nice to copy data from one table over to another. When you do, you can copy only some of the data from an existing table and move it into another table. This is often done to create like a buffer. If you're an advanced programmer, you've seen working with buffers as a standard design pattern. Here's how you might do it with SQL. This may be a little bit advanced, but I kind of wanted to give you a little look into how this might be useful in a practical sense. That's a question I often get. What I'm going to do is I'm going to use an option here to create a temporary table called orders demo. The pound sign indicates it's temporary. As soon as I close the connection, the temporary table will disappear. I'm pulling data from the Northwind orders table. Northwind orders table. And with this command, it's just made a complete copy of the orders table into my temporary table order demo. 830 rows were copied. And now I can just go ahead and work with the copy. That's handy for doing things like working with report data and just messing around with things. I'm going to do the same kind of thing by making a new table called orders to process. With this one, I'm going to copy the data from my previous temporary table. Well, actually, that's not quite true. What I'm going to do is I'm actually going to start to copy the data and then change my mind. What will happen is that it will make a table that matches the ordered demos table, which matched the orders table, with the correct number of columns, the column names, the data types for each column. But when it tries to actually copy the rows over, I'm going to say, no, I'm going to ignore the copying of the data. I'll do so with a cute little trick by indicating a false statement. If I indicate that I only want the rows where 5 is equal to 7, it won't copy any rows because there's never any time where 5 equals 7. And as such, what we end up with, is an empty table. I should only ran the one. If I look at the orders to process table, let's see, what is your problem here? Apparently running the first one canceled the second one. Okay. I look at this, I can see that the table's made and all the columns have been copied over and all the data has been chosen for me. It's a quick and easy way to make a copy of the table. It's also copied over the auto number feature, which is the auto increment. I'm going to turn that feature temporarily off by turning on the ability to insert data into a identity column. Identity insert on allows me to insert data into the auto number column or identity column. Now I'll insert some data by selecting only the top 10 rows of data from the table. I'll turn the identity insert off. You usually only turn it on and off temporarily. Delete 10 rows from the original table. And now, instead of having 830 rows of data, we have 820 rows of data in the original table and 10 rows in the orders to process. What this does is it allows me to only process 10 rows at a time. This is used for things like web programming, where you have a large amount of orders coming in from like a website. And what I want to do is I want to handle a batch of 10 rows at a time, finish processing those, grab another 10, finish processing those, grab another 10. Instead of actually being overloaded with a large random number of orders to process, depending on who's pressing the order button on a website. Anyway, it's a complex kind of example, but it's a practical example that you might see in the real world using the top command. If that made sense to you, excellent. If it didn't make that much sense, don't worry about it. Just put in the back of your mind that people use the top command for practical purposes. And this is one. Before I finish up here, I want to talk a little bit more about grouping data and coming up with subtotals. So let's take a look at the group by statement once again. We looked at it earlier. This will give us a chance to kind of go back to it. Let's look at the pubs database this time. I've got this title called BU 1032. Actually, it's called the Busy Executives Database Guide. In the sales table, I don't have the name, but I do have the number. I can see that there are a total of quantity of 15 books sold with that particular title. I'm going to group those sales of that particular book together so that by using the group by statement like we did earlier with a sum of 15. Five and 10, 15. Much easier to understand example than when I'm working with something like that temporary table and queuing things up. So hopefully by now that makes sense. The group by statement is pretty simple. Just once you kind of get your head wrapped around it, all things are kind of relative. Now let's add another feature. The feature I'm going to add is the with rollup option. The with rollup option is part of the group by. And when I use this, in addition to having the individual titles grouped together, I'm going to end up with a grand total. I have rolled up all of these individual groupings into a grand total. That's actually kind of handy. Now, if I would leave that off, and I would take this information and move it into something like an Excel spreadsheet. I could easily just go ahead and get the grand total, rolling up the total, by just pasting that data into Excel and then looking at the aggregates, putting some functions together. Let's see, where's auto sum? There we go. That's the same thing. However, if you don't want to go to the additional effort of copying and pasting things over, the with Rollup is somewhat useful, at least on occasion anyway. One thing to note is that if the group by is affecting multiple columns, you need to indicate which column you want to roll up. What I mean by that is, well, let's take a look here. Should I BU 1032? Oops, I haven't rolled these up yet. Excuse me, I haven't grouped these together because they were sold at two different stores. Let's add a rollup. Notice that when I add the rollup, we see the actual total. Where are you, BU 1032? No, actually, we don't see it there. We see it on a single basis on the store, but the store's ID has been aggregated. It's been rolled up based on the store ID. The reason for that is because the store ID is the name of the column right next to group by. If I switch that around and put title ID right next to group by, we'll see it. There it is. What this says is that regardless of the store, what's the total on the book? Whereas previously, regardless of the title, regardless of the title, I don't care about the title, what is the total for that store? If you want to get all combinations, instead of using with rollup, you can use with cube. With cube, it gives you all possible combinations. So for here, it's regardless of the store for that one title, we've got the quantity of 15. Scrolling down, we see the combination of I don't care about the store and I don't care about the title. What was the grand total? Scrolling down a little bit further, we see that I don't care about the title, I just care about the store. What was the total for that store? It's all the possible combinations when I use the cube option. As you start getting into SQL programming, you'll start running very complex reporting queries, doing things like combining data from multiple tables, titles and sales, and then the stores table as well, so 1, 2, 3 tables, and using group by and cube to get all the possible combinations. One function I think is really useful for making reports like that is the isNull function. What it does is it allows you to replace a null value with something else. So for example, I see a null value here. I would like to replace it when it finds a null value in the title column with all titles, because that's what it really is. For the Eric the Red books, regardless of the title, so for all titles, what was the quantity? That would be 8. If you take into account the title, it's 3 and 5. You can use the isNull function to make your report results look a little bit nicer. And on occasions where it's all stores, you can see that as well. All stars, all titles. You know, what I don't see up here is I don't see a column alias. So what I should be doing is I should add that on. Let me bump this down a little bit. I'll stack it vertically. And I put a column alias on, either at the back or at the front. If I put it in the back, I got to use the as keyword. If I put it in the front, I have to use an equal sign. Let's see if that looks any better. Excellent. Now I have a nice report query that I could then take and maybe copy over as data into Excel spreadsheet and start using that for various things like making reports. Let's see, only want all stores, and then go through and say something like quick analysis, data bars, or anything else. Well, that will get you started on some basics of how to use a select statement, and a little bit more. I added on some more advanced stuff towards the end. There's just so much in SQL, but if you just practice those basics, I think you'll be surprised how far you can get. Remember that you can always download and play with this by just getting the download of the Northwind database and the pubs database, and then just kind of following along in the video, typing out the code. Do that for a while, and I think you'll be more comfortable with SQL in no time. Thanks for watching. Take care.